Have you ever watched a customer support ticket bounce between 3 of your different agents and then have a customer rage quit after having to explain their issue for the third time? Here's why. Misrouted tickets don't just waste your team's time. They also kill customer trust and spike churn. I see most teams trying to fix that problem with a chatbot, but that just makes it worse. So instead of building another chatbot, I built this particular team a solution that addressed the root cause. In under a week, we cut the misroutes by 89%. Hi, I'm Rok. I've built AI systems at enterprise scale and in messy startups. After years of watching these projects fall apart for the same reasons, I started helping founders building AI that actually sticks. In my last video, I walked you through a 6-step process behind every AI support project that I have ever built. Today, we're gonna specifically zoom into step 1 and how one structured layer can cut misroutes by 89% in under a week, without ever touching a chatbot. Here's what this company was dealing with before we started. 27% of tickets were going to the wrong person. Agents were spending about 40% of their time just figuring what the ticket is all about. The founders assumed that this was a problem that can be solved by a chatbot. It wasn't. The real issue? No structure. Raw tickets flying in, everybody overwhelmed. So you can't patch that with a chatbot. Chatbots don't fix the chaos. They just amplify it. You don't need a crystal ball at that point yet. You need a structure. You need clean, predictable, composable outputs that you can build upon. So instead of trying to make the chatbot smarter, we made the problem simpler. That meant starting with one key question. How can we force every incoming ticket to fit into a structure that we can work with? The answer wasn't prompt engineering. It was simple engineering. It was enforced structure with Pydantic and Instructor, two libraries in Python, wrapped in a LangGraph workflow that we could expand on later. Now, if some of these names sound unfamiliar, don't worry. Let me give you a 10-second rundown of what I used for this project, but you don't have to remember the names. We're using LangGraph here, which is a workflow orchestration library. It's pretty low level. It enables you to do basically whatever you want. It's just a very neat way of organizing your workflows. We're also using Instructor, which is a library by Jason Lee. It basically forces the AI, the large language models, to give us structured outputs. So basically in a format that we want, as opposed to whatever the large language model wants. We're using Pydantic, which is another Python library, and that just catches errors. So before they cause any issues downstream in the system and cause some sort of a meltdown. And then the project itself, the UI that you're going to see, is built with Streamlit. It's a lightweight UI library, can be built in hours, and it's just there to show your team what they're working with and make it easier for them. So again, you don't have to remember the tool names, just remember this. Instead of AI that kind of works, we build it with guardrails. They're not perfect for your use case or for many other use cases out there. They can be quickly tailored to be, and you can build on top of that. So let me show you how this all fits together. Okay, so what users see at this point, we're building a ticket classification step. I'm going to explain the user flow for that particular step, and how it goes is that the user uploads a CSV. There's some background processes going on that we'll dive into in a minute. Those background processes run. The result is then displayed to the user, so the user has live feedback. They immediately see what is the distribution of the classified tickets. They immediately see how each ticket is classified, and they can also download the CSV to upload it to their own tools and for further processing. And that's just a basic overview, and now we're gonna dive deeper into it. Now, what happens a layer below that is, so there's some sort of an engine room where these processes are gonna get orchestrated. For now, we only have one process, which is the classifier node. So what happens is the ticket comes in, this node gets executed. In future videos, we're going to also build the router node, the summarizer node, and so on. So then those workflows are gonna continue. You could orchestrate them in different ways. You could put them in parallels. You can execute them sequentially. Because we're using LangGraph, it's pretty easy to control that. So in the third layer, the brain, so the AI part, the ticket comes in, we send it to the AI, but via instructor, which is a Python library, we determine what are the categories that we allow the AI to classify our tickets in. Then we use Pydantic to validate that those are the outputs of the AI align with the categories that we have predetermined, and only then do we export that to the CSV, which the user can download then. So the magic here is not the model. We're here actually using a pretty small one, GPT-4o mini. The magic isn't prompt engineering. It's engineering and giving AI a structure. Every output is validated before we export it to a CSV. Every category is one of a predefined ones. And if the model fails, no problem. We catch it, we log it, and we move on. There's no hallucinations. There's no surprises. Okay, so that's a bit of a high-level overview. And now let us dive straight into the code. So here's the repository that I've built for this specific tutorial. Okay, so I'm gonna walk you through the code. I'm gonna explain why things are where they are, and what's their purpose, as opposed to going through the code line by line. The repository is linked in the description below, so if you're interested, if you want to start quickly, you can just clone it, use it. You can get your team to adjust it to your specific use cases in probably a few minutes. Okay, so let's start with the real business categories, not the generic ones like positive sentiment. Our business categories are the tickets that we want the LLM to classify each specific ticket into. So we don't want the LLM to come up with 180 different categories on its own that it feels might be the right ones, but we know which categories we have, and we just want the LLM to classify the tickets in those categories. So this is exactly how we're using the Pydantic model to determine that. And as you can see, those are actually the real categories from a real example. And this is how they had them displayed then in their system, which we should also always follow. As we're building AI systems, we should follow the real-world examples. The real-world systems shouldn't adjust because we came up with something new. We need to integrate with existing stuff. So that's the model. So these categories here, they aren't just labels, they're constraints. So with this, we're actually forcing the large language model to fit every ticket into clear buckets that your teams can use. Not maybe it's this, maybe it's that answers, but very clean structure. So routing, analytics, and anything you want to build on top of the ticket classification is starting with a good basis. So it all runs on solid grounds. So in code, we call those enums, in short for enumerators. It just means that only those values and nothing else. So why would that matter to you? By limiting AI to your actual categories, you get consistency and not creativity. And consistency is what you need when you want to classify tickets. That means fewer errors, faster decisions, way less cleanup later. You can actually start relying on AI with this. Okay, so we come to the next piece of the puzzle, which is the classifier. That's the part that actually talks to the AI, but not in the way that you're used to. So let me explain that. So instead of crafting some super clever prompt and allowing AI to basically come up with some answer that it thinks it's appropriate, we're just saying something super simple here. Classify this customer support ticket into the most appropriate category. We're not relying on the prompt because we don't want to hope that AI will follow our prompt. So basically, we're using a tool called instructor, use to call the LLM through. So here we're instantiating it, and here is where we're actually calling the LLM, and we're passing this ticket classification model in. Now, if you remember from the previous step, this ticket classification model determines what categories are allowed for the LLM to classify a ticket in. So that's a very, very simple way of telling the LLM, hey, I want exactly this. This is the format, pre-fill it, instead of leaving a blank piece of paper for the LLM to be creative. We don't want any deviations here. Okay, so if we have a product question bought online, we don't want the LLM to come up with product bought online or product question bought online all in small caps. So this is how we actually determine what is it going to reply. So the thing is that this library also reruns a couple of times the attempt. If the LLM would come up with something different that we defined here, we would immediately validate it programmatically, send it back, and allow it to redo, to have another go at it. So the wrong output is not let through the rest of the system and pollutes it further. So we catch the bad outputs right there, instead of your customer support team having to deal with them weeks or months later. Okay, so the next file is graph.py. And this is a part where we orchestrate the workflow. Now, currently everything is in one file, and that doesn't really matter because the scope is pretty small of what this application does at the moment. In later videos, we're going to break this down a little bit, and we're going to also, make sure that each node is in its own file. Okay, so this is the build classification graph. That's kind of a core function, and it builds our workflow. Our workflow has only one node, so one step in the whole process, which is classifying the tickets. Later on, we're going to add more nodes in a pretty straightforward way. Literally, what we're going to do is we're going to add, let's say, summarizer or router. And it's going to be a router node. And we're just going to create another router node ticket, router node function. But for now, let's just keep it like that. We're not just using now LangGraph because it's fancy to have it. We're using it to build easy and to scale easy in the future. We're using it for control, for future growth. Every team has had this moment when they had to add more features on a foundation that was not really built to scale, and it became unmanageable. So this is how you prevent those things early on. You have a way of breaking down those flows and orchestrating them in a very neat way. How LangGraph works is basically you have some sort of a state. If I explain in a simplified way, those nodes have states. The state can be persisted throughout the workflow, so through multiple nodes. In that state, you define what you're going to store. So basically, you could be passing on some sort of outputs from previous nodes and use them as inputs of subsequent nodes. So LangGraph gives us a clear separation of steps. The classification stays clean. The routing will have its own node. Summarization, another one. Each can evolve independently without breaking the previous one. So one node today means 5 nodes tomorrow without rewriting everything. So right now, this LangGraph workflow is already a full working course. This means when we're going to add a routing node and then or summarization, even plug in CRM data, we just add new nodes there. No rewrites, no refactoring, no spaghetti code. Each step stays clean, independent, and testable. This is how we go from a simple demo to a scalable production system seamlessly, without ever needing to rebuild the whole thing. Let's quickly talk through a UI. So why did we even build the UI at this stage, right? I mean, if this is supposed to be a customer support bot, isn't supposed to be integrated with Gorgeous or Zendesk. Yeah, true. But this UI, it's tactical. So this is a throwaway code. It's not meant for production. It's not beautiful, but it does solve one of the biggest problems of AI implementation, which is keeping the domain experts close, because that just means more work on their end. That's hard to do. And you need them close to the development process to make sure your foundation is built well. So imagine just building this classifier and building 5 different things on top of it, and then just plugging this into Gorgeous and Zendesk or whichever system you use, and wishing everybody good luck. People might have a lot more work and confusion in the following days. If it's even slightly off, even more tickets is going to get misrouted. Customers are going to get ignored. Support team will be losing their trust into the system. You don't want that, because that will severely hinge adoption. So instead of then having those regular catch-ups where you debate with the customer support team what works and what doesn't, and everybody goes out of this meeting confused, even more engineers and the support team, you can just build this throwaway UI, and it's literally 120 lines of code under an hour, and you can really deploy it in minutes. So it's just so the engineers get the verification that they're on the right track, and the customer support gets to get their feedback conveyed because they're the ones that are handling the tickets. They know how they should be categorized. So here we have a few utility functions. We really want to validate that the format of the CSV is correct before we let the user upload it. Yeah, once the AI comes back with the results for the tickets, we are writing them in a CSV back and preparing them to be downloaded. That's pretty much the whole application. And here we have the data. So that's just, we have some example data here that we're going to use in our demo. So this is our throwaway UI that we've built for the sole purpose of keeping the customer support in close in the loop before continuing. Imagine this wouldn't really work that well, and we would already be way further down the line. This prevents that type of mistakes. What we do here is we take our CSV just to make sure the customer team is on the same page as us. We gave some instructions here, how the CSV should be structured, and we upload a CSV. So we can just quickly check whether we uploaded the right one. Yes, seems like this is the right one. And now we're going to run it. We're going to classify our tickets. Okay, so we can quickly have some sort of an overview of what is going on. So what is going on here is that the majority of tickets seems to be shipping and tracking related. So that might be already something that the company is not aware of. So this could be a good part to look into. The rest of them, keep in mind, this is just 22 examples, so we're not going to see a lot of insights here. But yeah, so you can see that this can give you already some sort of indication of what is happening with your customer inquiries. Here you can see a little bit more visualized pie chart, which tells you what is the distribution of those tickets. And here you can quickly check whether everything is correct, whether all the tickets have gotten their category, which seems to be the case. And that was done pretty quickly. Now we can just download our CSV and we can quickly check, and we can see we have functional CSV file that we've downloaded. We can upload it to our ERP, to what kind of system, whatever kind of system that we're using for further processing, or just to give feedback to the engineering team, which was actually the point in this step of the whole solution. So as mentioned, this low effort throwaway UI code makes sure your agents, your support leads, people who actually handle tickets, test them directly. They don't need any technical skills, no devs in the room. They can just do it on their own time. They just upload a CSV, they see the classifications, and then they download it, check it, and give us the feedback. This is how we make sure that the foundation is solid before we keep on building, and this really prevents this to collapse. Most projects don't collapse because the AI is bad. They collapse because those kinds of things. Bad assumptions go untested until it's too late. So this UI makes sure that doesn't happen. So it's worth the investment. Okay, so before we wrap, I wanted to show you one more thing. Just the other day I read an article about how many AI projects are out there and how little of them have any sort of evaluations. So that's basically the only way that you're guaranteeing at a scale that your product is reliable. So those tests here, they're pretty basic to start with. They don't just validate the code, they help you trust the system. So what do I mean by that? So when you're rolling out the AI in your support flow, the number one question that your team is going to ask is, how do we know this actually works? So it can take weeks to build custom evaluation pipelines, but you don't need all that complexity when you just start off. You just need something that tells you whether you're on the right track. You need to start validating today, so you need to build it fast. So what I did here is I added simple unit tests, simple assertion-based API calls to the LLMs. It's quite predictable what the LLM will return. In our case, it's going to return one of the few category labels that we allow the LLM to give us back. And we kind of know for those example questions what the labels should be. So then we're going to just double check whether the label is correct. So how do we do that? Let me quickly show you. So we're going to quickly open the terminal and we're going to run this one. And as you can see, pretty quick, right? So less than a second for the answer for each ticket to come. And seems like all of our tickets are passing. For this one, we were expecting to be shipping and tracking. example it was. For this one, we expected the order issue, this one a product question, this one should be a wholesales inquiry, website, collab. So basically all our tests passed, and that's just an example how you can structure them. You can add your examples and more of them. One cool thing to show you is also those tests don't just run locally. I also built a CI/CD pipeline in the repo that is linked in the description. So we can run this every time there's a change and we push that change to the main branch. These tests are going to run. So you update these tests and your specific examples are going to run. So you make a change, let's say in the ticket classification model, and you run the tests and they'll fail. Well, that will immediately show you that something is going wrong here. Okay, so this is our customer support AI project. Let me show you quickly. Let me quickly do a small change to the code so you'll see these tests running in action. Let's quickly create a new branch. Let's call it test PR. Let's just go here in the README, just this, save it. Okay, we're going to do a test PR against main because this is what will trigger the workflow. Okay, as we can see, those assertion-based evaluations that we created are going to run. So this is pretty cool. With GitHub Actions, we have isolated environment that basically installs our environment in a Docker container. So what is happening now is that GitHub is installing all the dependencies that we have to run this particular application. And here we go. So yeah, pretty fast again, a little bit more or less than half a second per ticket. It ran all of our tests, and because our tests passed, the workflow passed. This is how we know every time we're going to do some sort of change that it didn't break anything from before. So yeah, now we can merge this PR. That's pretty much that. Okay, so why this matters to you? This is not over-engineering. This is the smallest possible step towards building trust with your team. Because if your support lead asks, how can we trust this system or this ticket classifier? Now you can run 6, 10, 50 tests in a matter of seconds to prove them. So this is how we avoid surprises in production, and this is how we make AI safe to use and safe to adopt, not risky to deploy. Okay, so what did this actually give the business? It didn't just give them clean categories, not some AI working in the background. It gave them 89% fewer misroutes, instantly saving agent hours and getting customers less annoyed. It gave them actionable data from week number 1 for routing, staffing, automation, gave them a structure that won't break every time something changes. It gave them the confidence that what's working today will still be working tomorrow. And most importantly, a system they can actually trust and grow with. And yeah, for now, it's just step 1. But it unlocks everything else while already bringing value. Classification might seem basic, but if this part isn't right, then nothing else matters. Because we used LangGraph, this is not just those one-off prototypes. You can actually use it and build on top of what's already working. You want to add the routing layer? Easy, we'll do it together. A summarization, that's just another node. You want to enrich it with customer text? Great, create a new node and build that logic in isolation, while still being connected to your whole workflow. You can just plug it in. The whole thing is built to evolve fast and safely. The truth is, you don't need a massive system. You just need something simple that your team can trust, use from day one, and build upon. So the full code base for this exact system is linked below in the description. You can clone it, run it, and tweak the categories to adjust to your business in just about under an hour. So there's no fluff, there's just working, structured AI you can build on top of. And that's just the beginning. In the following videos, like I've mentioned a couple of times, we're going to build on top of what we created today. We'll add automatic ticket routing, we'll add summarization of long threads, we'll add data enrichment all the way till we'll actually generate replies. So stay tuned. If you want to see how to scale AI in customer support one layer at a time, make sure you've subscribed. If you're trying to figure out where to start and what not to waste your time on building, there's a link in the description to book a free strategy call with me, or just DM me on LinkedIn. Happy to help you figure it out. Now hit that like button and see you in the next one.